All right, so it says find the x and y intercepts of the following equations. So number one, if I have y equals x squared plus 1. To find the y-intercept, you set x equal to 0. So y equals 0 squared plus 1. Y equals 1, so my y-intercept is 0, 1. To find the x-intercept, you set y equal to 0 and solve. So if I plug in 0 for y, now I need to solve that, subtract 1, square root both sides. So you're going to get plus or minus I equals x. Since I'm not getting a real number, there's no x-intercepts. Let's look at another one. Let's look at number 2. If I wanted to find the x-intercept, we set y equal to 0 and solve. So 0 equals the square root of x minus 2. To cancel the square root, square both sides. And 2. So then I get 2, 0. And then for my y-intercept, we set 0 for x. So I get y equals the square root of 0 minus 2. I have a negative inside of a square root, so no y-intercept. Let's look at number 3. So if I wanted to find the x-intercept, plug in 0 for y. So x plus 2 squared plus 0 squared equals 16. Square root both sides. I'm going to pretend that's 0 and not there. So I get x plus 2 equals plus or minus 4. Subtract 2 on both sides. So negative 2 plus 4, negative 2 minus 4, right? Plus or minus means there's two versions, one with the plus, one with the minus. So I get x equals 2 and negative 6. So my x-intercepts are negative 6, 0 and 2, 0. Now for my y-intercept, I have to plug in 0 for x. So I get 0 plus 2 squared plus y squared equals 16. That's 4, so subtract 4 on both sides. Square root both sides. Now I got to break up that 12. So that breaks into root 4 and root 3. Root 4 is 2. So that's going to be 0, 2 root 3, and 0, negative 2 root 3. All right, number 6, it says describe the given relation using either the roster or the set builder. So I'm going to copy and paste this over there. So it'll be a little easier for us to visualize. All right. So I know this is a relation. So I'm going to have x and y. And the reason why I'm not writing it specific is because it seems like there's multiple x values, there's multiple y values. So now let's look at what x is. So it starts at negative 4 and ends at 5. So x starts at negative 4 and ends at 5. Now because it's a dotted line or a dashed line, that's why I didn't say equal to. And then my y, same thing. Starts at negative 3, ends at positive 2. So my y starts at negative 3, ends at positive 2. Let's look at another one. So for this one, it seems like my x value is -2 because it can only be on -2. I don't see any other x values, but my y, there's multiple y values. And then it seems like my y starts at -4 and ends at 3. So my y starts at -4 inclusive and ends at 3 exclusive. So number 10 says graph the given relation. So it says my x is less than or equal to 3. So it's going to be kind of shaded on that side. And my y is less than 2. And it's going to be, it's less than that. So this is where they overlap. Number 11 says solve each of the quadratic equations. So when we solve a quadratic equation, it's easiest to see if we can factor it first. So a times c, 15. Do the factors of 15 add to -8. So 1 and 15, 3 and 5. So if they're both negative, so we break apart factor by grouping. So you factor out what's in common, which is x. Factor out what's in common, which is -5. So we get x minus 3 and x minus 5. So since it's set equal to 0, the zero product principle. So we set each of these equal to 0. Add 3. Add 5. So that's my answer. And then the next one, you might be able to factor this, but to not overthink it, we're just going to use the quadratic formula just so we can remember it. So -b plus or minus the square root of b squared minus 4ac all over 2a. We're going to plug those in. A, B, and C. Two times A. Now from there, you just need to simplify it.